next thing we want to learn about radicals is basically how do we rationalize an expression. And what that means is our proper format whenever we have a fraction is to not have a square root or any kind of root on the bottom of our fraction. So we don't want to have any roots at all on the denominator. That's our standard form. We don't want to have that happening. So what do we do to get rid of them? We are going to get rid of this fraction that has a denominator that has a root by multiplying the numerator and the denominator by some fraction of an appropriate form. Okay, what does that mean? That means I want to use the rules that I just found out about in the last video by using those properties of radicals to cancel out the root on the denominator. So I'm going to show you how we can do that. If we have a over the root of b, what I want to do is actually multiply by something that is equivalent to 1 because I don't want to change the value of my fraction, but I do want to cancel out that root on the bottom. So why am I doing that? Well, we know from our last video on the properties of radicals that, first of all, across the top here, I can't really do any simplifying. It just becomes a times the root of b. But on the bottom, the root of b times the root of b can be simplified. It can look like this, the square root of b times b. Well, b times b is b squared. So I have the square root of b squared on my denominator. What do I know about those two operations? When I square something and I take the square root, well, they're opposite operations, so they end up canceling each other out. And what am I left with? I'm left with a root of b over b. So that's what's called rationalizing our denominator. In other words, we are trying to make sure that we don't have any root signs on our denominator. Let's try the same thing with our other question here, and I'll do this one in green. So I have 6 over the square root of 3, and I would like to make sure that I do not have any square root signs on the bottom of my fraction, on my denominator. So what am I going to multiply by? By the root of 3 over the root of 3. Why am I doing that? So that across the top I end up with this, but on the bottom I end up with the root of 3 times 3. Again, same thing. 3 squared and then square rooted, well, those are opposite operations. So what will I end up with? 6 times by the root of 3 over 3. I can actually simplify that a little bit. So why don't I take this one step further, and I'm going to use the fact that 6 divided by 3 will give me 2. And I can simplify it one step further to write this. 2 times by the root of 3. That's how I rationalize the denominator. So what do I do if I'd like to rationalize the denominator, but I have something like this, where I have 2 separate terms on the bottom of my fraction, on my denominator? So, again, I want to multiply my fraction by another fraction that's equivalent to 1. In other words, it has the same thing on the top and the bottom. But what I would like to do is to multiply so that I end up with no roots on the bottom. So what I'm going to multiply by is this. I'm going to show you an example here. So why am I doing that? Let's go across the top here first, and I'm not really going to do any combining or distributing here. I'm just going to write it like this, a bracket root of b minus root of c. We're going to leave it that way. And I'm actually going to multiply. So I have 2 terms on the bottom here, root of b plus root of c, and root of b minus the root of c. Let's go on to our next step here. So the top is going to stay the same. And what happens on the bottom? Well, I actually need to multiply to do this. So I have the square root of b times the square root of b. What does that give me? That gives me, well, the root of b squared, which is just b. I have the square root of b times the square root of negative c. So that gives me negative square root of b times the square root of c. And I'm just going to leave it like that for now. Next 2 terms, let me switch colors here. I have square root of c times the square root of b. So plus square root of c times the square root of b. And the last one, square root of c times the negative square root of c. What does that give me? Gives me negative root c squared. Same thing as for the first term in this. That simplifies to a negative c. So what do I have going on here? What do we notice about these two terms in the middle? Well, I've got root b, root c, root b. Well, those two things are the same because it doesn't matter what order we multiply in. So these are effectively the same terms, except one of them is negative. So they actually cancel each other out. We end up with 0. So what is our final answer going to be? A times root b minus root c, our initial thing that we multiply by, over b minus c. So now we can see that we no longer have any roots on the denominator, and we've transformed our original improperly written fraction into something where there are no roots on the denominator. Let's try another example. We'll use real numbers this time. So we have 8 over the root of 2 plus the root of 5. Going to do a very similar step. I'm going to multiply it by the root of 2 minus the root of 5, like that. And we're going to make sure that we do end up with something that has, it's okay to have a root on the top of my fraction, but it's not okay for it to be on the denominator. So I'll do the same thing as before. I'm just going to leave it in a bracket. Over, multiply our first terms here. So root of 2 times root of 2 just gives us a 2. Root of 2 times the negative root 5 gives us that. Multiply here, so plus root 5 root 2 minus 5. Okay? Same thing as before. It doesn't matter that those two are written in a different order. Those two things are the same term, except one is negative and one is positive. So what happens? They cancel each other out, and we're left with this. Let's simplify that a little bit more. So we have 8 times the root of 2 minus the root of 5 over 2 minus 5, which would give me a negative 3. And normally we would not leave our negative on the denominator, so I'm actually going to move it so that it is out in front of my fraction. So this is going to be my final rationalized expression.